Yeah, this is actually an issue with the power power shortage. So yeah, sorry for that. Anyways, let's continue. So anyways, yeah, if someone is gonna leave right now, he or she should be able to watch it recorded. So yeah, so let's continue. And what we are doing here is essentially enchaining, but we are not enchaining into the chains. It may seem quite illogical, but you'll get there. You will be enchaining into an array of chunks, proxy chunks. So if we are operating, you are operating among the links or the segments of the chain, which are essentially chunks, by the way, or belts if we are talking about details. But we can certainly iterate over the chunks or belts directly. And that's what exactly we're going to do with these proxies. And yeah, so basically, if we wanted to iterate using the chunk proxies, we're basically going to like introducing a bunch of for loops. So this is the first one. Now, what is exactly this thing? This thing is actually pretty trivial. It's going to iterate over all possible chunks that are matching this filter, this exact filter. So, for example, if you're having a single chunk here, so you're absolutely sure that you're spawning the subjects using like only a single trait. So all of your subjects are essentially the same and having a single trait. You will just be getting a single iteration here. And so, yeah, this is like direct access for the chunks themselves. And now we're going to like introduce a new variable, and it's gonna be chunk proxy. And this one is directly accessed by this array. So yeah, this is what we're actually beginning from an array. So again, this is all quite logical, isn't it? These chunk proxies, they're having uh, a bunch of chunks actually embedded in them, and we're getting each of them. And now, while we actually have a chunk, um, we can just call it chunk, so it's pretty transparent. It's a proxy, but we can call it like that. We can iterate all of the subjects within this chunk. We call when we are like addressing the contents of the chunks, we're actually not calling them subjects. So, for example, within the belts, there can actually be multiple iterations within the same slot. And just for the sake of consistency, we're calling them slots. So they are slots within the chunks. And now we're going to iterate over all slots within the chunk. And basically, in another loop. Yeah, it's important to say that by default, during this in-chain operation, the chunk gets locked. So for each proxy chunk, the chunk it refers to, it proxifies, is actually, it's gonna be locked. So only when you're like exiting this scope, exiting this iterating process, the chunk will actually be unlocked and essentially be available for all sorts of other operations. So if you want to make it like really modular, if you want to introduce some other mechanics after that one, you should be doing something like that. So you should be like scoping these chunk proxies, so they will automatically unlock those corresponding chunks when they are out of scope. Essentially, we're going to be simplistic here, so it doesn't need that. Yeah, and then chunk proxy iterated over it, all of its slots. And what do we actually need within this proxy? So we need a trait, a vector trait. So let's just chunk proxy trait reference at, and the reference will be of type f vector trait. Yeah, so now we can just use it as pretty much the same as, yeah, of course, it's at position J. So what this construct essentially says is that we are acquiring a trait by reference at the J's slot of the chunk proxy, of the current chunk proxy. And we will be implementing vector, up vector, delta time, pretty much the same thing. What doesn't? Of course, we have to use a vector here. So yeah, this is how our direct iterating process would look like. If this loop gets more sophisticated, if the logic within this loop gets more sophisticated, it can actually be troublesome. So, as you're all aware, subjects are like traveling all over the place when they get new traits, when they spawn, and when they despawn, and things like that. And every chunk slot can actually be invalid in this case. And if there is a possibility for this to happen, you actually have to check for the subject for the slot to be valid and to be able to be iterated correctly. So, for example, this is done like with the is stale at continue. So if the current slot is actually not the true slot, if it's already been gone to some other chunk, perhaps, you should be, oh, maybe, no. Oh, yeah, no. You should be hearing from myself. Yeah. So let me just check it so people don't get me wrong. So one of our colleagues called. Anyways, yeah. So again, you're using the direct access iterating, perhaps because you want like really optimized workflow, really performant loops. And if you're going to check this thing here, you can also actually check for the chunk proxy at JS. If it's having a certain flag. Stuff like that. So if you're like, if you're introducing like more and more entities, more concepts to this iterating process. Hello, Eli. Well, you have to like keep yourself aware that there is a price to pay, even for this like really trivial. If this mechanic is pretty trivial in its own, it's gonna be it is gonna cost something. So all of our like idea of direct chunk iterating is for this not to happen. So to minimize these checks. So if you're um, if you're really sure that there are no stale subjects, no stale slots, and the flag mark checks are essentially not considered, or maybe you're willing to take this risk, so you should be removing this in the first place. And we're going to be testing that just this very bare case. And yeah, let's go and launch the editor, shall we? So yeah, Eli, if it's actually the moment you've joined us, we are now testing the new direct iterating workflow, and it can get you some milliseconds. If your mechanical really like trivial, but most certainly it won't be, but still gotta deliver some kind of a fine-tuning possibility. So yeah, let's just, where is our measurement? It's here. Okay, so we're going to be using the proxy chunks now. The threads count, well, we're not going to be using threads. Of course, yeah, by the way, if you're like going these direct access iterating, you can implement your own threading mechanism. So you can create new tasks here, Unreal Engine's native tasks. You can like separate the iterating process into multiple like batches. So the same chunk can be iterated in multiple threads, but you should be doing this manually. You get this functionality like by default when using the operating construct, operate concurrently, for example. And yeah, if you're going the manual way, you have to do everything by hand, essentially, including the multi-threading. So let's actually measure what we will be getting using the new proxy chunks. Yeah, same thing here. Just making sure that we're going with the shipping project version, since we're like we need really optimized code here. And yeah, just to make a note, again, when you're using the trait reference at method here, it's really optimized. It's actually compile time optimized, so it won't be searching for traits, for separate traits, won't be like searched for. The indices will be resolved during the construction phase, so you shouldn't be worrying about this thing being ineffective. It's really effective. Да нет, мы на самом деле просто показываем, как теперь можно итерировать по чанкам напрямую, то есть без использования вот этого механизма оперейта, а просто брать, засовывать их как бы в прокси, делать им инчейн, в этот массив проксей, и уже потом по этому массиву проксей просто итерироваться под ним прямыми for-лупами. То есть все механизмы проверок, которые здесь в Operate уже по умолчанию, здесь их надо будет делать либо смысленно, либо наоборот их удалять, если они там performance как-то нагибают, так чувствуется. That's actually an answer for Ili in the native, in our own native language. То есть это, иными словами, это прям вот, чтобы получить прям максимальный перформанс, естественно, пожертвовав удобством. Yeah, and it should be noted that, of course, we can't really, these like one single for loop, C++ for loop, it's not really possible to beat it in terms of performance, because it's basically unwrapped into some really optimized code. But you're essentially not able to use this stuff in a general purpose environment, or it will be held to implement such stuff using just a simple arrays, obviously. So your world is always dynamic. Traits are added and removed all of the time, and you won't be able to use it as simply as that. And you need a tool like Apparatus or Mess, the new Unreal Engines Mess, in order to like be versatile, be all sorts, to be able to implement all sorts of mechanics with different like topology dynamics or structural changes, obviously. So this is like really raw and plain and cool, but it's not really usable in the real life as long as your entities are not absolutely the same or have the same topology, same structure. And this is just the case of like really optimized loop. So you can't really get past this thing. So it's like I don't know, a perfect or ideal to reach, not something that's actually usable. And yeah, we're getting like 4 we're getting like 2 for loops here, but it's essentially gonna be 1 exactly, since there is only 1 chunk. But let's just test it. Let's just test it. Was the build successful? I sure think it was, yes. Chunk proxy method. So it was, let's just make it out again. So plain array 2.3 milliseconds, 2.4. Now let's get it to the chunk proxy way. So it's 8 milliseconds. So 8 and 6, 8 and 5 milliseconds. It's still quite, I don't know, substantially higher than the for loop, the native for loop. But again, it's a construct that's actually usable in the real world environment. And if we'll just compare it to the normal apparatus iterating, let's just threads, yeah. Let's create a new build just in case. So it's one single threaded operate. Eight and a half milliseconds for 2 million subjects. Now let's try this thing. So it's really having a footprint here. It's the default apparatus way of iterating. So it's operate concurrently. It doesn't really matter one single thread. It's basically a single threaded operate. So it's about, let's say, more than 2 times faster. So the direct proxy chunk, proxified chunks iterated is actually quite substantially faster. And it won't actually be that noticeable if you implement some real world mechanics, because obviously those are pretty trivial, almost non-existent ones here. I mean, this thing is pretty much nothing. Yeah, only the cost of the for loops or the operate concurrently or operate construction is measured here. But yeah, if you're like going all the way for the performance, you should consider our new proxy chunks. And yeah, we can actually like boost it up a little bit. It won't actually change, shouldn't. I haven't tested, so I want to explicitly test this thing. Just to make sure. This really shouldn't change anything, but maybe some kind of a sophisticated optimization will take place. Let's see it. let's call it like that, so it makes some actual sense. So it's even slower, really? How can it be? Oh, really? It's a bit slower. So the two for loops are actually faster than the one. That's strange. That surely is strange. Oh, come on, really? How can it be slower? Should double check. Should just double check it. I'm not believing it. This thing is actually faster. Hmm. That's surely weird. Not really important for us again. Hmm. What's wrong? Seems like it's stuck. Hmm. Well, that's surely quite strange. Uh-huh. All these processes. Why? Why are not? Why they? For some reason they don't exit. Okay. Yeah, while this thing builds some notes about the mess. So let's just yes, this video.
I don't care what you're doing, you need to stop and listen to this interview.
Such a wonderful discovery.
The clarity of it is euphoric.
It totally rewrote my understanding of the world.
Brings about the true liberation.
Design comes into place.
So this is important, and it's important to compare to what we're actually. Yeah, this one is actually succeeded. These enormous thing, these like not really hard to manage thing is what you're getting when you're using NAS currently. And all of this stuff is basically handled by apparatus now. So you don't have to like use this transform lists, views, or something like that. It's basically, yeah, it's basically chunk based. So you have to like use these chunks. So it's kind of like our direct iterating process, direct chunk based iterating process. But again, it's even in that case, it's not really usable. Lots of garbage, I'd say, here and here. Not the best design choice, or maybe it's not, well, it's simply not there if we're talking about the current state of the NAS. And we're actually going to adapt the message workflow in terms of you will be able eventually to use both mass, its entities, its fragments, and use them inside your classical apparatus operating. So it's not really hard to like use these like concepts within apparatus or to bring them into apparatus. So we are now considering to make some kind of adapter, a special adapter. So if for some reason, I don't know why, but for some reason you will need to use the mass, and perhaps you're using it in some other project or something like that, but you still want to bring the usefulness and the usability of the apparatus, you'll be able to merge them together. And we are certainly looking into this, obviously a competitive solution, but I'm pretty sure we're already ahead in so many ways, including the blueprints, obviously, but in terms of usability and the whole like paradigm of operating, of iterating, it's simply it's too basic, and it's too cumbersome at this moment. So yeah, but anyways, I'm totally fine in using some kind of a compatibility layer to be able to use the systems that are already written for the mass, perhaps some animation stuff, and to bring it to apparatus. Sounds cool, isn't it? So anyways, yeah, we've built the version. Let's now try. I still don't believe this is working. Slow. So it's 8 milliseconds. Yeah, it's kind of faster than the. That's quite mind-opening, I'd say. Yeah, it's slower. Well, anyways, you should be almost always using the exactly 2 for loops here. So yeah, and yeah, so this is the new functionality behind the chunk proxies. Gotta use them wisely, obviously. Gotta safe check certain things. Gotta design for them specifically to be able to use them effectively and safely. And yeah, so this is what I was to talk about, the new feature that I was to talk about today. And it's quite important to understand where we're actually heading now. And beside the possible compatibility layer with the mass to use its own systems and to adapt them, I will most certainly go for the lockstep solution, our own lockstep solution. So now the networking is pretty versatile. It's pretty self-sufficient. It covers lots of scenarios, really. So it's fine. It's usable, but it's kind of not trendy. I think that's the whole replication system. It's a bit shaky, and I don't really like it much, honestly. As a whole, doesn't matter if it's Unreal Engine's based on or maybe some other replication system, but I most certainly think that the full-fledged lockstep is actually beneficial for the community, and it's actually beneficial for the industry. So yeah, we're going to make a lockstep solution, a general purpose one. What does this actually mean? You already can implement lockstep. Not that it's not that difficult within the current apparatus states. It's totally doable, but we need some certain functionality, some certain deterministic routines, some certain deterministic libraries in order to do that. And we're targeted towards delivering this functionality. And yeah, so both math, vector routines, I don't know, collision detection, pathfinding, things like that. So you should be expecting apparatus to become more of a platform of its own. Again, we are totally fine with using Unreal Engine and some of its like internal, even core systems. It's so well tested, well built, let's say like that. But we kind of have our own vision for the whole infrastructure of the perfect world for technical game development. And most certainly we are enjoying Unreal Engine's rendering capabilities, including those that are of newer 5 version. And yeah, but we're going to continue to grow like our foundational stuff. So Apparatus is becoming a platform of its own, and more things are expected to be brought into Apparatus to become an ecosystem of itself. Certainly some things have to be addressed before that, like for example the manuals, the tutorials, so gotta expect this to happen. And I'm currently like all the way writing some missing manual pages. Again, the API documentation, I would insist that it's pretty complete. Every public API is documented like to the bone, but people need, especially newcomers, they need some tutorials, they need some kickstarting manuals, and we are going to target this as well. And yeah, so this is basically what our vision is. So creating a better like learning curve for the newcomers and really expanding the apparatus to becoming more of a self-sufficient platform of its own. And yeah, so that's basically it. I hope you get like some new really usable information. I will be streaming hopefully the next weekend as well, because I have to cover like some more basic stuff again, useful for the newcomers. And you should be asking any questions that you're like puzzled with today, and we're going no matter what. Let's say we're totally into getting yourself comfortable in order to be effective using apparatus, in order to be able to achieve what your goals are today. And so let's see what we've got from yours. And your projects are always welcome to show, even privately, as some people do. And yeah, they're looking pretty cool, pretty, I don't know how to say it, well, pretty well engineered. Hopefully they play as good as they look. And yeah, so drop a message, drop a question, and we get you covered. We're all for that. Thank you for watching, for joining us on today's stream, and hopefully see you next time. See you guys. Keep on operating.